In this video, we're going to talk about rational exponents. Okay, remember rational, we talked before, is just a fancy way of saying fraction. So these are going to be fractional exponents. Okay, so anytime you have an a to the 1 over n power, okay, the exponent is 1 over n, that's really the same root as the nth, or same as the nth root of a. So, for example, if I have 81 to the 1/2 power, that's really saying the square root of 81. And what is the square root of 81? Well, that's just 9, okay? Similarly, negative 27 to the 1/3 power, well, that's just the third root, or cube root, of negative 27, which, what number, when I multiply it, when I cube it, gives me negative 27? Well, that's just negative 3. Okay. The 81 over 16 to the 1/4 power is the same as the fourth root of 81 over 16. And we say, okay, well, the fourth root of 81 is 3. Good. And the fourth root of 16 is 2. It's not very good. 3. I should fix that. So we write this as 3 halves. Here we go again. 1/2 power means square root, and what I have here is 25 x to the 4th and y squared. Well, I could really write that as the square root of 5x squared y, quantity squared, right? So I'm looking at the square root of something squared. Okay, and so when I take the square root of something squared, remember then that is going to give me a 5x squared and a y. But remember, as we talked about in our last lesson, when we take the square root of something that is an even square root, we have to add those absolute values in order to ensure that it's positive. Now, interestingly enough here, the 5 already is positive. And the x squared, no matter what x is, that's already positive. So the only thing that has to stay in the square root, or in the absolute values, excuse me, is the y. But I would take it either way. I'm fine with that, okay? Similarly here, we have the cube root of negative 27 y to the 3rd. Okay, and so then we would say, okay, well, that's the same as the cube root of negative 3y, and that's cubed, right? Because negative 3 cubed, that's 27, y cubed, and so our answer is negative 3y. Doesn't need to have absolute values because it's an odd root, so no problem there. So that was if it was 1 over n. Now we're going to talk about m over n. And the m and the n become our root. N is still our root. And the m becomes the power inside of our variable. Now, interestingly enough, it can be either way. There are 2 different ways to write it. And you're going to have to be comfortable with both of them, right? So a to the m over n power is the nth root of a to the m inside. Or we can say the nth root of a to the m power, okay? So let's take a look at this first one, all right? So here I have 9 to the 3/2 power. So that's really the square root of 9 to the 3rd power, okay? Well, what is the square root of 9? That's just 3. 3 to the 3rd power is, 3 times 3 is 81. And 3 times 3 is 9, and 9 times 3 is 27. So 3 to the 3rd power is 27. Good. How about this one? Negative 125 to the 2/3 power. So again, I'm doing the cube root, because that's the denominator of the fraction, negative 125, and I'm raising that to the 2nd power, because that's the numerator of our fraction. Well, the cube root of negative 125 is negative 5, and when I square that, I get 25. Okay, similarly, we're just going to keep right on going here. This is going to give me the fifth root of negative 32. And I'm going to raise that to the fourth power. Oh, you know what? Actually, let me back up here. This negative doesn't actually belong to the 32. It is going to be like negative 1 times 32 to the 4/5. That's interesting. Sorry, I just now caught that. So I'm doing negative 1 times the fifth root of 32 to the fourth power. Well, the fifth root of 32 is 2. 2 to the fourth is 2 times 2, which is 4, times 2, which is 8, times 2, which is 16. So this gives me negative 1 times 16, which is negative 16. You really have to be careful. Notice the difference here. This negative 125 is all in parentheses, so it all stays together. Whereas this negative here with the 32 is not in parentheses, so it's really negative 1 times the 32, which has the exponent. I'm sure we'll talk more about that as time goes on. Okay. This is going to give me the square root of 9y to the fourth, all raised to the third power. Okay, so that's really the square root of 3y squared squared. So now I know how to take the square root of it. And then that whole thing is to the third power. So when I take the square root of 3y squared, that's just 3y squared. And then I'm raising that to the third power, which you should remember how to do. 3 to the third, that's 27. And y squared to the third, when I raise that power to a power, that gives me y to the sixth. And our last one, I'm taking the cube root of negative 8x to the third, and I'm raising that to the fourth power. Well, this becomes the cube root of negative 2. Okay, so negative 2x all to the third power, right? And then cube root of negative, and then that whole thing is raised to the fourth power. So then that gives me cube root negative 2x to the third is negative 2x, and then I'm raising that to the fourth power. So negative 2 times negative 2 times negative 2 times negative 2 is a positive 16, and x to the fourth. Okay? So that's how we're going to start working with those rational exponents and how that translates into a radical. Okay, we'll see you in the next one.